Welcome to Mechatronics Laboratory. So now we are going to see about assembly language programming of 8085 addition, subtraction, multiplication, division. The aim of the experiment is write a program for addition and subtraction, multiplication, division of two 8-bit number 8085 microprocessor. Apparatus required is 8085 microprocessor and a keyboard interfacing kit. So this is the architecture of 8085 microprocessor. So in that inside of the microprocessor we having interrupt control, which is used for give the integer input and output. In that serial input output control also it is used to control the SID serial input data and serial output data. And then in control module it's having the ALU arithmetic logical units, the flag register and the temporary register as well as accumulator. So in arithmetic logic unit which is used for to give the arithmetic logical operation, that means addition, subtraction, multiplication, division. So accumulator which is used for to give the extra space to the ALU. If there is any space is not enough means it will give the additional space. So the values are stored into the register with the help of the instruction. We are entering the opcode. The opcode is entered in the microprocessor. It will be stored into the instruction register as well as the instruction decoder and machine cycle encoder. So here address bus and data bus buffers are there. So it is give the address. Normally we are using address some value 6C00 7000 7001. So that address are stored in this portion. Here this is a timing and control module. It will be used for to give the timing of the execution. Normally we are giving some time limit, means the time limit which is controlled with the help of the timing and control module. So this is a sample program for addition. So before you have to enter into the opcode, so you have to know something about opcode. So normally we give the command move a, that is opcode is 74. So that move value is stored into the 24H address location. So we giving opcode is 74 and 24, and then move F0 means you load the register of B. So that opcode is 75 and F0. Here we are giving 42 as input. So in the two input 24 and 42, it will be do the addition operation. That is a short form of ADD. ADD means addition. The opcode is 25. The output of the 24 and 42 will be stored into the F0 location. So and then return to the command mode is 22. So in microprocessor we are giving 24 and 42 as a input, two values. The additional two input value will be displayed as 66. So first you have to press the S key, then double enter, then address 7000 you have to give that, then you enter the opcode, then you have to execute that, you can get the 66 output. So this is a simple program for subtraction. So only one difference is same opcodes we are using the command, the sub command. The previous program we are using addition, here we are using subtract. So we are using sub command. The opcode is 95, remaining all same. So we are giving two input as a 55 and 10 to the different memory addresses. So these two numbers are subtracted. So finally we can get the answer as a 45. Here we are using move a move out opcode means 74. We are giving a location value as 55. Then move F0. The load of the register B is 75. The values will be loaded to in the register is 10. Both value 55 and 10 will be subtracted. So the opcode is 95. The result of the subtraction will be stored into the register A, that is F0. Finally, it will be returned to the command mode, that is initial mode. So this is a sample program of multiplication. So we are giving move a, that is 74 opcode, and we are giving value as 11. Then move F0 is we are giving value as 05. Then the 11 and 5, that value is multiplied with the help of the opcode A4. Then it is returned to initial position. So sound 11 and 5, it will be multiplied. It will show the output of the values of 55. 11. This is a sample program for division. So we are giving the two values. One is 55, another one is 5. 55 is divided into 5. We can get the output is 11. Only one difference, we are using division command. That opcode is 84. So you have to type the program and execute means we can get the answer is 11. So press integer, then press S key, double enter. So it will ask the address. So you have to give the address as 7000. Then you have to give the enter. So you have to type the values. So in 1000 we are giving the value of 74. You type 74, then give enter. Then you give the value of another address which is 7001. You are giving the command for 24, then enter. Then 7002 you give the output of 75. It is already there means just enter. If it is not the coming means you have to enter 75. Then give, then you type F0, then 42, then 25. That is return position. Final one is 7007. So if you press, after typing that, press escape key in keyboard, press G key, give double enter. It will ask address. So give 7000, give enter. So it will shows that wait and done. Is there means any error is there. Is suppose if you type any code mismatch in output means it will not show as a wait. So you can easily understand the program is either right or wrong. So we are typing the right program, so it will show us wait and done. And then you give press S key, enter, press any key except CR and escape key, and give double enter. The addition of 24 and 42, it will be added. 22 and 44, sorry, 24 and 42 is addition of the two number is 66. The output is displayed. So similarly you have to type the subtraction and multiplication and division programs and you execute that, you can get the output. The result of the program is that's the 8-bit numbers are stored into the address of 7000 and the values are added and subtracted and multiplied, we said, and the results are stored. Thank you.